2, 3. There are 3 terms. It's a trinomial. Term 1 has a square. So this is a quadratic trinomial. Okay. So this here is a quadratic trinomial. Let's write them in this right hand now. So this is a quadratic trinomial. Quadratic trinomial is ax squared plus bx plus c. It's just that now you don't have the x here. X is being replaced by a plus b. It can be replaced by anything. You must not get confused. What you can do is you can take this and simplify it. Make it simple for yourself, okay, by using a substitution. So you can use a substitution. You can let a plus b, because a plus b is something that's common here. Can you see that? So let a plus b equal to x or k or y or z, whatever you want to. It's just a substitution. So if I let a plus b equal to x, so therefore we now have x squared minus 2x plus 1. And now it's a simple quadratic. Can you see that? So now this is equal to, it's a simple quadratic, not like 6 where you have to go and play around with the numbers. This is just a 1 here. So it's simple. So that's there and there. So I know if it's a minus plus, it will always be a minus minus. Always. Minus plus must change to minus minus. Why? Because if you add 2 negatives, the middle term is negative. If you multiply 2 negatives, the last term is positive. You can see that x squared can only be x and x. 1 will be just 1 and 1 there. So now, be careful with this. When you have repeated factors, okay, it's important that you simplify them further. The example is if I have k times k times k times k. We learned that if the bases are the same and you are multiplying, you write down the base once and you add the exponents. 1 plus 1 plus 1 plus 1 is 4. Can you see that? So this is the same thing. It's just that it's not k, it's x minus 1. So you must go further and write it as x minus 1 all squared. It's very important, this part here, especially when you come to n5 and all that there, when you deal with partial fractions. You have to factorize it fully in this form. Right, so that is this. Any question on this one here? This one is straightforward. You would have, okay, got it, yes.
Yes, sir. So if you, is it okay if you substitute here the a plus b, because you swapped around the x, is it fine if you substitute it back to the x?
Oh, sorry. Yes, my mistake here. I'm busy focusing on the factorization. I forgot to substitute back. Yes, sorry, my mistake then. We used a substitution. We need to substitute back. Right, so what is x? X is a plus b, and then we got minus 1 all squared. Sorry, now that was not full marks. I just lost 1 mark here because I forgot to substitute back. If I was writing the exam, I lost 1 mark there. You can see that. Yes, so substitution, you must substitute back. Can you do anything further there? No. So this is the final answer. Here is simplify these fractions. Okay, now what do we notice? We have this division here. Okay. And above the division sign, I'm adding fractions. Below the division sign, I'm also, in this case, I'm subtracting fractions. Okay. So if I have something like a over b divided by x over y, if I have a fraction divided by a fraction, what I do is I copy down the top fraction. This division will change to multiplication, and then the bottom fraction, you swap numerator and denominator. So that will become y over x, and then you now have a fraction multiplied by a fraction. So it's numerator times numerator, denominator times denominator. Right, so this works when you have a single fraction. That means the fraction needs to have one common denominator on the top, one common denominator in the bottom. The denominator is common already. So if your denominator is common, then you will write down the denominator one time only. We're clear with that? It's like if I have 1 over 4 plus 4 over 4, my denominator is common, so I write down my denominator once and then I work out the top. That's going to be 5 over 4. So my denominator is common, square root A, write it down once, and then I got 1 plus 3 there, which is 4 in the bottom. Square root A again is common, write it down once, 7 minus 3 here is 4. Now, as I said that you normally do this, but clearly it is unnecessary to go any further and use our laws of fractions. Why? Because we got two things which are exactly the same. They are identical. Anything divided by itself. And I wouldn't say anything. Okay, almost anything. 0 divided by 0 is not 1. Infinity divided by infinity is not 1. But anything else divided by itself is 1. These are identical. That was a straightforward 2 marks there. This one, 7 marks now. Okay, let's see why it was 7 marks. So, we got a fraction divided by a fraction. It's just that we are not using a line, we are using this symbol here for division now. It could have been given to you as that, all divided by this in the bottom. It means the same thing. Alright, so now you would have done many examples before. So clearly when you look at this, straight away on the top, you can see, now you will have to factorize this. Count how many terms here, 1, 2, 3, 4. So normally when you have 4 terms, you use the method of grouping here. Okay, so we take 2, group them, take the other 2, group them, common factor and common factor. If you have 4 terms. So let's see if that is true. Okay, so I notice now we got a minus ax minus bx. So the first 2 terms, clearly I can take out a common factor there. What will be my common factor? Now if I use, you are saying x. So if I take out x, let me just show you why x is wrong. Okay, let me show you why. Now the fact that you are saying x, let me show you what happens. So if I take out x, I'm going to be left with minus a minus b. Then you notice that y is common here. So you take out y, then you left with b plus a, and now we got a problem now. Can you see that? So taking out x, okay, it will now, you will have to do an extra step and realize that you still have to take out minus 1. So although you are wrong, you can still correct it, you understand? But you, doing many examples, you must know, obviously you must take out the negative sign. So now you take out minus s, so what are you left with? A plus b. Check, negative times positive is negative, negative times positive, negative again. Here, okay, obviously I'm going to take out y, so I'm left with b plus a, all divided by x minus y. Now this division sign, again same thing, this division sign must change to multiplication. So there's my multiplication. Right, so what we're going to do is we're going to swap numerator and denominator. Now this 8a squared minus 15b squared, it looks like the difference of 2 squares there. Okay, can you see that? It looks like the difference of 2 squares. So we know that the difference of 2 squares, if we have x squared minus y squared, it's equal to x minus 1, x plus 1. Okay. But we need to have perfect squares here. But the problem is the 8 and the 50. Okay. So we need to first take out the highest common factor before we apply the difference of 2 squares. So what we're going to do then, okay, let's show it here now since we have to do it. What will the highest common factor here be? That will enable us to do the next step, which is apply this formula. So if I take out 2, if I take out 2, what am I going to be left with? 2 times 4 is 8, so that will be 4a squared. I know 4 is a perfect square, that's 2 squared. I can apply it minus 25. We know that 25 is 5 squared, so we know it's going to work out nicely now. Times b squared, all divided now. The denominator, now this is going to come to the bottom. Now let's see what is going to happen here. Now, let's try and factorize this one. So there, this is a trinomial. Clearly it's a trinomial. I can see that. Which you got 1, 2, 3 terms. So if you got a 2a squared, it can only be 2a and a. Then if you got 5, it can only be 5 and 1. But now, if I put the 5 to the side here, and I put the 1 to the side, let me just put it as 5b, 1b here. Let's see if it's going to work. We're checking the middle term. 2 times 5 is 10. 1 times 1, that is 1. So 10 and 1, the difference, if you add 10 and 1, it gives you 11. This is not 11. If you subtract 10 minus 1, you get 9. It's not 9, so this is not correct. So let's swap it around. Let's put the 5b here and the 1b here. Okay. Now let's check the middle term. 2 times 1 is 2. Then we got 5 times 1 is 5. Now we got a 2 and a 5. What can we do with 2 and 5? We can add it up, we get 7. Is this 7? No. If we subtract 5 minus 2, you get 3. So we know it's the correct combination. Now it's all about the signs. So we know that it must be a negative. So therefore, this must be the negative and this must be the positive here, because we're going to get 2a times b will be plus 2ab minus 5ab. So you keep the sign of the larger term when you're adding. So that's it for this one. All we have to do now is factorize here the difference of 2 squares. So let's do that. And we need to factorize here further too. Can you all see that? So what is a common factor? A plus b is common. So you take out a plus b. What am I left with now? If I took out a plus b from here, I'm left with minus x. I took out a plus b, so I'm left with plus y. In the denominator, I got x minus y. Okay. Now, times 2. Now, the difference of 2 squares here. Okay, so 4a squared. Let me just do it in order. I'm just going to show you all working on this side, and then I'm just going to do it at one time. Right? So that's 4a squared minus 25b squared. So we know that 4 is 2 squared. You know that 25 is 5 squared. So, you got 2 squared times a squared, which is the same as 2a all squared. 5 squared times b squared, which is the same as 5b all squared. This is showing every single thing. But obviously, once you know it, then you go straight from here to here, and it's straight from here to the final answer. So this is going to be a minus b, or x minus y, that's your x, that's your y. X minus y, so that will be 2a minus 5b x plus y, 2a plus 5. So let's write that down. That is 2a minus 5b, 2a plus 5b, all divided by, in the denominator there, 2a minus 5b, and then we got a plus b. Now, let's see. We factorized. What cancels now? Let's see what cancels at the moment. Alright, so clearly that and that will cancel. A plus B will cancel. Nothing else as it stands here. Okay, but there's something. If you look at these two factors over here, okay, the only difference between them is the signs. Okay, so what remains? Let me show you what remains. What we have here is minus x plus y over x minus y times 2 times 2a plus 5b. Okay, so what can we do here? All you do is take out negative 1 as a common factor from these two terms here, or take out negative 1 from the denominator if you want to. You have a choice, it's up to you. So if I take out minus 1 here, then you know when you take out a negative, all the signs will change. The negative x will become a plus x. Plus y will become minus y all over x minus y times 2. And that's 2a plus 5b. So now, let's see what happens. That and that will cancel. So you end up with minus 2 times 2a plus 5b. Leave it in factorized form. How can we check if this is correct? You will have to substitute values for a, for x, and for b in your calculator. Okay, and you just do it as it is. And then you do this here, this part also. Okay. Any question, any problem here with this one? Anyway, can you see a mistake anyway? No. Not dealing with logs. Alright, so this is similar to the grade 12 type of questions. Okay, so if log 2 is equal to a, write log 50 in terms of a. Okay. So now what we have is, we have log 50. Okay, so what can we do to the number 50? There's different ways of writing down 50. We got 50 is equal to 10 times 5. 10 times 5 is 50. Okay. 50 is equal to 25 times 2. What can we do here? So now, remember that log of a over b is the same as log a minus log b. And then if I got a log of a times b is the same as log a plus log b. So if we have division, it changes to subtraction from the log logs, and multiplication will change to addition. Okay, so since let's try out 25 times 2 and let's see what happens. Okay, is it going to help us in any way? So now if I go log of 25 times 2, let's see if this is going to help us. If it doesn't work, let's try out something else. Alright, so we're going log of 25 times 2 because 25 times 2 is 50. Okay, so I got log 25 plus log 2. Okay, then I know that log 2 is equal to a. So I got my a there. The problem is the log 25. Can you see that? It can be done. We can go further here. Now, okay, one more thing I need to show you. Okay, so it'll be more clear. We know that log x to the base x is equal to, if these two numbers are the same, as long as that x must not equal to 1 and x must be greater than 0, as long as they are not these two numbers here, then log x to the base x is equal to 1. Why am I showing you this here? Okay, because if I have log of 10 to the base 10. What is log of 10 to the base 10? Is equal to 1. What happens if I have log 100 to the base 10? What is log of 100 to the base 10? So now we know that 100 is 10 squared. And there's your base 10. Can you see that? So now if I have an exponent, I can bring it down. So that's going to be 2 log 10 to the base 10. And what is log 10 to the base 10? 1. So therefore 2 times 1 is equal to 2. So now using this information here, okay, using this information, this important information to work out this problem. So let me go back to the log 50 now. Let me go back to 50. Here, I was showing you multiplication. It can work if I do it that way. But now what happens if we use division? 50 is equal to 100. Why am I using 100? Because I know that log of 100 is equal to what? 2. Can you see that? So 50 is equal to 100 divided by 2. So I'm going to write 50 as 100 divided by 2. And now I'm going to use the law. When you are dividing, it's going to change to subtraction. So therefore it's going to be log 100 minus log 2. What is log of 100? I just showed you here now. Log of 100 is 2 minus, and we have a value for log 2. What is log 2? This will be a faster way. The other way you could have done it, because 25 can be written as 100 divided by 4. It's just that it's going to take too long, but it can work anyway. Right? 10 times 5, 2, you can use 25 times 2, but 100 divided by 2 gets you to the answer faster. You can see this. Okay, we move on to question 2.2, which is solve for x. You can see we're dealing with exponents here. Okay, this one is 6 marks. What can we do? You would have done many examples like this here before. Okay, obviously maybe they're confusing you on the right hand side here, putting the square root, but on the left hand side, this is something that you have done many times before. Okay, because it's clear, you've got 2 to the power 2x, 2 to the power 2x. So what are you going to write for x? As 2 squared, which is going to become 2 to the power 2x. Right, so let's start. On the left hand side, we got 2 to the power 2x. So what am I going to do? I'm going to split this up. It's going to become times 2 to the power minus 1. It'll be minus 2 to the power 2x. The denominator is going to be 2 squared, and all raised to the power x is going to become 2 to the power 2. Let me just show you in detail here. 4 to the power x is actually 2 squared, all raised to the power x. So when you have a power raised to a higher power, you multiply the exponent. So that's 2 to the power 2x, and that's how I got this part here. Can you see that? Now, here I don't see anything. I'm just going to leave it as it is for now. I don't see any, anything happening if I change this. Right, so, but clearly on the left hand side, I notice that 2 to the power 2x is a common factor in the numerator there. Can you see that? So if I take it out as a common factor, what am I left with? I took it out, I'm left with 2 to the power minus 1 minus 1. Okay. Because 2 to the power x times minus 1 is minus 2 to the power 2x. Denominator, 2 to the power 2x, and now I'm left with this here. So it's clear now, that and that will cancel. Okay, so now I've got 2 to the power minus 1, which is 1 over 2 minus 1. Let me take this to the left hand side also. And I got plus 1 is equal to the square root of 2 to the power minus 3x. Okay, this minus 1 was a separate term there, you can see that. Now what am I trying to do now? I want to isolate. That means I want the part with the square root alone on one side. So I got minus 1 plus 1, that's 0, so I just got the half is equal to the square root of 2 to the power minus 3x. What do you think I should do now? So get rid of the square root. Square both sides, or I can do this here. We can square both sides if you want to, or now I can use the exponent law. I notice now that this is a 2. This is also a 2 here. Can you see that? So 1 over 2 can be written as 2 to the power minus 1. Then here, if I have x, a, b, and I want to convert this from surd form to exponential form, this can be written as x to the power a over b. Are you clear with that? Okay. So, what's the number here if it's not shown? It's a 2. So, your b here is 2, your a is minus 3x, so that's going to be 2 to the power minus 3x over 2. You're clear with that? I'm converting from surd form to exponential form. What do I notice now? Equal bases. So you will equate exponents. If the bases are equal, that means if the base on the left is equal to the base on the right, so you equate the exponent on the left must be equal to the exponent on the right. So minus 1 must equal to minus 3 over 2x. And now we can just divide by minus 3 over 2. So therefore x is going to equal to 2 over 3. Is that the correct answer? Let me check this quickly. Give me that calculator then. That one there. You check your answer. Make sure you check your answer. So take this, substitute into the left hand side. Let me just type that out. So that's 2 to the power 2x minus 1 minus 2 to the power 2x. And in the denominator I got 4 to the power x. Okay, let me just do the whole thing one time. Minus square root of 2 to the power minus 3x minus 1. So let's substitute this value, 2 over 3. Yes, it's perfect, it works. Okay, so what I'm doing is I'm substituting into the left hand side and into the right hand side, and the left must equal to the right. Or if you take this whole thing and if you take the right, if you take all the terms on the right, move it to the left, and the equation will equal to what? 0. Then you substitute for x, and if you get 0, you know it's perfect. This answer is perfect, it satisfies the equation.